Hello and welcome to this video tutorial for Creo Parametric version 3. The content of this video tutorial is parameters and relations. So as the name Creo Parametric implies, this is parametric software in that the user can define dimensions or variables and then form relationships that have functions on those rather. So in this example of a flange, so quite a simple model, if we have a look at the workflow, it's simply a revolved surface with a thicken and a pattern for these locator holes. However, if we dig a little bit further, and if we go to the Tools and Relations tab, I have populated some text which describes both mathematical and logical relationships between, for example, the outer diameter of the flange and the inner diameter. So if I just OK this for the time being, and if I right click on the revolve, edit dimension, so I can edit dimensions on the fly, and if I change this from 45 to say 70 mils, you can see that the inner diameter has changed. The outer diameter has also changed with respect to that, and the number of locating holes has also changed. So in this sense, the entire model of this flange is parametrically driven by one dimension, the inner diameter of this hole. So needless to say, this parametric driven modeling is quite a powerful tool. So as you're aware by now, Creo does this implicitly with simple shapes like squares or circles or some shafts. But the real power for the user is the ability to define these relationships based on the model. So the general workflow is to create a model that roughly represents your finished product. Once you've done that, you can then name dimensions. So Creo uses a pretty crude and difficult naming convention. It's much more meaningful as a user to name them yourself. And once you've named that in the Relations tabs, you can then enter your relationships. So we'll see how that works with a new model. Okay, so I'll start with a new part, and I'll run through the modeling fairly quickly because you should be quite familiar with that, but I'll spend more time explaining the relationships and parameter part. So I'll make a simple revolve on the front plane here. I'll turn off my datum plane so it's a bit clearer. I can then right click to add an axis of revolution. Now I'm just going to roughly draw the outline of the flange, and I'm going to make this as a surface model. So it will be incomplete, and we'll just put in some more appropriate dimensions. These will change once we have fully defined our parameters. I'll click OK. I'll get a warning saying there's no enclosed geometry. We'll model this as a surface. That's fine. So we'll tick that. I'll then apply a thicken. So this is a shell or a surface object. So in the surface toolbox, I'll click thicken, and we'll make this 5 millimeters. I'll just change the direction there. Okay, the next step is to extrude some holes that will be patterned. So I'll click extrude, click on this face here. Within construction mode, I want to locate these holes on a pitch circle diameter that can change. So construction mode is useful for this. Click construction, draw a circle. It's quite faint to see because it's a light pink color. I'll set this to a strong dimension, so it's dark blue. I'll turn construction mode off and then draw in one of these holes. So I'll just rotate that out of plane, tick OK, and that's a through extrusion, but we want to extrude up to a surface, and we'll choose this bottom surface here. Okay, the final step is to apply a pattern. So I will click this extrude one in the workflow, click pattern. I want to turn my axes on because we want a pattern by an axis. I'll click my axis and it's defaulted to 4 times, offset by 90 degrees. That's fine. Tick OK. And there we have our rough model. So if I were to change that now, if I right clicked on my revolve, clicked edit dimension, and if I change that 40 into a 30, so this feature here has changed, but nothing else is adapted. So we're going to spend some time now defining parametric relationships, which will enforce the whole model to change based on our inner diameter. Okay, so the next step now is to name our dimensions that we can then refer to later on. So if I right-clicked my revolve in the work tree, click the dimensions, I can then name these and give these a more meaningful name. So they do look a bit cluttered, but if we select the inner dimension here, if we right-click and went properties, so Creo's named that D1 because it's the first item we've dimensioned. We'll change this to flange ID, or the inner diameter of this section. We'll click OK. So it's just a more meaningful name. This 70 mm here, we'll select, right click, properties, and we'll call this flange OD. So the outer diameter of the larger section. We'll click OK. We'll also select the height of 30 mils. Right click, properties, and we'll name this flange underscore H for height. It's really important to use underscores in your naming conventions all throughout Creo. Click OK. We'll then define the first extrusion, which is hiding in this pattern. So we can rename this pitch circle diameter. So if we right click, properties, and we'll change that from D7 to flange PCD. So that's what these holes are going to be located on. Press OK. Once again, we'll rename this hole to flange hole. Now in the pattern, we can then define the number of times and the angular offset of those patterns. So if we select our pattern, select this for extrudes. So this allows us to change the number of extrusions, whether it happens 5 times, 6 times, 7 times. Right click, properties, flange hole N for the number of times. And finally, the angular offset in the pattern, we'll right click that, properties, and call this flange hole angle. Okay, and we'll just click out of that. So that so far has only been a superficial change. We've changed the name of the dimension from the default Creo one to something that's more meaningful for us as humans. Okay, so if we jump into the Tools menu bar, we can start building some relations. So if we click Relations, we're presented with a blank canvas. Now we can do all sorts of mathematical or logical operations here. So we can do addition, subtraction, multiplication. We can also include if or else statements, and we can do other logical functions. So I'll start by setting the outer diameter of the flange equal to 2.5 times the inner diameter. So we'll go flange OD, so this is why we named them logically, equals flange ID times 2.5. So if we press OK, now we may have to regenerate this model by clicking the orange traffic light button. It's saying there's an issue here with the regeneration. We can click regenerate, and the outer diameter here is now 2.5 times our inner diameter. So if we right click revolve, check the dimensions, we can see we have 30 mil here and 75 mil. If I was to change that to say 20, so our diameter shrunk, our outer diameter is still 2.5 times, but we've got issues with our locating holes. So we'll change that back. And the way we can fix that is within our relations. So I'll set the flange PCD equal to the flange internal diameter times, let's go 1.75. We've actually defined this PCD as a pitch circle radius, so I'll have to divide that by 2, my mistake. And I'll regenerate. So now, if I right-clicked on the revolve, click the dimension, change that to 20, the location of the holes then changes appropriately. Put that back to 50. Now the final thing we'll look at is if we were to enlarge this diameter, we want to add more locating holes. So this is where we can use logical if statements. So in our Relations tab, we can say if the flange ID is less than 50 mil, we will set the flange number of holes to 4, and we'll set the angle underscore there to 90 degrees. And then we finish that with end if. If the flange ID is greater than or equal to 50 millimeters, the number of holes will equal 8, and the flange hole angle offset will equal 45 degrees. We'll finish that with end if. Press OK. We can also tick the tick box to make sure our relationships are valid. We can then regenerate our model, and it's now populated that with 8 holes. because our diameter here is equal to or greater than 50. And if we change this back to 40 mil, so due to our logic, our 8 holes have gone back down to 4, and the size has changed based on the pitch circle diameter. So that wraps up a whirlwind look at relationships and parameters. So once again, the general workflow is to do a rough sketch or rough model of our part. Once we're happy with that, we can then name our dimensions by right-clicking our work tree features, showing our dimensions, selecting and naming them. And once we've completed that, we can then enter mathematical and logical relationships. So quite a powerful tool for building complex models with interrelated features.